Good evening. We're going to talk about computer vision today. I'm Reza Zadeh. I'm an adjunct professor at Stanford and CEO at Maitreya. We're going to talk about computer vision, and in particular, we're going to talk about scaling convolutional neural networks with Kubernetes and Tensor Flow, all of which will be sitting on AWS. That's why we're here, right? So, quick introduction and overview. We're going to have a very fast introduction to Kubernetes and to Tensor Flow. And then I'm going to give you the pods, the Kubernetes pods that we use for Maitreya. And then I'm actually going to go into a live demo of Maitreya and show you all of what I presented earlier in the talk live in action. So just to set things up, we're going to get to this place here, where we have our own video player. This is Maitreya's video player. It has been given a detector that we will build. This particular detector is detecting Brad Pitt and Angelina Jolie. In some interview, it has put bounding boxes around their faces, and this is a paused version of this video. The rest of the video is actually has been annotated with where these folks occur. So if you look at the timeline, it's been generally annotated with where Angelina and Brad occur, and this is where we want to be. So we're gonna create a detector for them. We're gonna grab a random YouTube video, put it in here, and watch the Kubernetes and TensorFlow gears churn to give us a screen like that. So, Kubernetes, or sometimes abbreviated K8s. The basic unit in a Kubernetes cluster is a pod. And Kubernetes, if you didn't know, is a cluster management tool. So you can manage a fleet of machines and their workloads using this tool. The basic unit in a Kubernetes cluster is a pod. A pod is consisting of one or more containers. And a container is a very much lightweight virtual machine. If you don't know what a container is, it's like a very lightweight virtual machine. It's not really a virtual machine, but it can be abstracted as one, and the implementation makes it much more lightweight. Containers in a pod share one IP address. So a pod is this basic unit that Kubernetes will ensure are fault tolerant. So if a pod goes down, Kubernetes will bring it back up. A pod can be replicated via Kubernetes. And the interesting thing is that all the pods in a single, all of the containers in a single pod share one IP address. So you have to be a little bit careful with clashing ports because you have one single IP address. But other than that, it's actually a very, very useful abstraction to have all of the pods have one IP address. So Kubernetes handles much of the scaling and the fault tolerance. And this is a very, very simplified overview of what a cluster looks like to the end user of Kubernetes. There's the Kubernetes master. There are a bunch of minions. Inside, and these are machines. Inside each of these minions, there are one or more pods. And inside each of those pods are one or more containers. And by far, Docker containers have sort of taken the lead here. And so we use Docker containers, and I'm not going to talk about any other kinds of containers. So this is very much simplified. Because if you think about it, well, what if the master goes down? Who's going to fix that? What if one of the minions goes down? Who's going to fix that? This is very, very simplified. The true diagram for Kubernetes looks more like this. And here, in the middle, there's some distributed storage that is replicated across many machines in case Kubernetes needs to redo some work that has been lost. So we're actually not going to have the privilege of diving deep into this. The slides for this talk will be available on my Twitter, and there's a link here to tell you more about that. I'm going to actually go into more of a use case for Kubernetes. How do we schedule pods? How do we split up a computer vision task using TensorFlow and other tools to build on top of Kubernetes? So I don't have the privilege of going deep into this, but I'll definitely link to it in my slides. Actually, the link is already there, so the slides will be up is what I mean. So let me go into the architecture that we have for Maitreya. We have pods for each of the logos you see here. And they're necessary for reasons that you'll see in the demo. So very quickly, we have a pod for Nginx, which is a reverse proxy. It does load balancing for our web server. The web server, the web app itself, is Node.js. We have many streams of video coming at us in Kafka. And then I'm going to go into these in a second. So let's look at these pods one by one, why they exist, why did we put them in a pod in the first place. So the first pod is Nginx. This pod is essentially responsible for the very first contact with the user. It is sitting at port 80. When the user comes in, Nginx will decide which of our many web workers to assign that user to. So then Nginx will route that. And Nginx gets its own entire pod, so that if it goes down, Kubernetes is responsible for bringing it back up. We have Node.js, which are the actual front-end workers for the web app. Now, when you've created a detector using the web app and all of its nice details, you can then have a stream come in through Apache Kafka. And Kafka has workers, it needs its own little cluster, and those are all managed by a pod in Kubernetes. We have, everything is securely encrypted. So of course, we need to serve SSL certificates, and those are provided via Let's Encrypt, which has its own pod. Our database is Mongo, right? That everyone needs a database, and that just happens to be Mongo for us. Of course, that's got its own pod, but this one is also backed up periodically because you better back up your database, right? That's a no-brainer. The Spot Marketplace, because we're at AWS, I want to give it a special slide on its own, so we'll come back to this. But this is a cost-saving measure that you'll see that is very specific to the Amazon Web Services environment with spot prices. I'll come back to that in 2 slides. And then, of course, we have convolutional neural networks via TensorFlow. So pretty much every deep learning framework supports neural networks, and convolutional neural networks in particular. And I want to, before going deeper into neural networks, I want to explain how neural networks work. And then I guess before that, I should tell you why we have our own spot instances. So this is a little bit, as I promised, I want to explain this, right? So we had this AWS pod. Why do we have that? Well, hands up if you know what a spot instance is. Great, almost everyone. So most people in the room understand that spot instances are cheaper instances of the instances that you can reserve from Amazon, right? You can get machines and you can say, I want the spot version. The caveat with the spot version versus reserved instance is that the spot instance might at any point be evicted. You get something like a few minutes of notice saying, hey, your machine is going to be evicted, and then you're going to get evicted. In return for dealing with this inconvenience, Amazon gives you a cheaper price. So we would like to actually exploit this cheaper price. So how do we do it? The workers that we have for TensorFlow, actually, they run on Amazon's spot instances. And then we have one pod that is a little tool that listens for all of these spot instances that are going to be shut down. And as soon as a spot instance gets notification that it is going to be shut down, it tells this pod that is running on a reserved instance that, hey, I'm about to be shut down. My work needs to be put somewhere else. So then this pod that is running on a reserved instance managed by Kubernetes will put up another pod that is reserved and that will not be taken down and put the work of the spot instance into the reserved instance. So this way we get away with essentially a cheaper version of our cluster and our service by having one reserved instance watching out for an army of spot instances. And that's a trick that you should use in your own Kubernetes clusters because it usually can save you a lot, okay? So what do we use these spot instances for? We use them in particular for this TensorFlow, pod. And what does a TensorFlow pod do? It runs a convolutional neural network. So the CNN is something I want to really, really quickly go over because a lot of folks in the room are probably comfortable with them, but I'm going to quickly do like a 3-minute overview of CNNs. What is a CNN? Unless you've been very far away from the media, you understand that deep learning is pretty powerful and can do a lot with computer vision. One of the main things that you can do with computer vision is understand what's going on in a picture, and then from there, a video. How do these things work? Well, the first thing that happens is we have a picture, and we want to decide. So here, the task is we have a picture. We want to decide which of 4 things it is: cat, dog, boat, and bird. What's going to happen is we're going to run this little 2-dimensional patch over the image. And inside this patch, there exist little numbers that are going to be multiplied by the color values at that point in the image. Those multiplications will get added up, and fed as the input to the next layer. And so what's happening here is this input to the next layer is then available for a similar operation in the next layer. And the numbers in the patch, we don't know what they are. Okay? We're going to set those numbers as variables. We don't know what they are. We'll set them in a second. And we're going to run this patch actually across the whole image with the same set of numbers. Oh, sorry, I keep hitting my big mouse pad here. With the same set of numbers across the image. And then that's one convolutional filter. And the numbers that we don't know how to set, we don't know how to set them, but we know how to take their gradient with respect to some data. So we have some function that fits some data. We know how to take the derivative of these numbers that we don't know how to set with respect to that function that is looking at the data. And then once we have that gradient via an algorithm called backpropagation that I'm not going to go into, we can actually train what these numbers should be. And that's what it means to train a neural network. So TensorFlow does this for you. So do pretty much any other deep learning frameworks out there. There is at least 10 deep learning frameworks out there. And they all support this, all of them. So I'm not going to go any more into that, but I wanted to at least tell you what's going on there, right? So we use TensorFlow because it has some features that we like in particular. It is actually entirely a coincidence that the name Matroid is related to the word tensor. The name Matroid is actually a generalization of a tensor. A tensor is a mathematical term, and a Matroid is in some ways a mathematical generalization of a tensor. Matroid was actually incorporated 1 month before TensorFlow came out. I did not know Google was going to call that this. It just so happened that we both are very close to the math, and we care about being named after something that is very much at the heart of all of this. So the TensorFlow needs a lot of compute power. This compute power usually comes from P2 and P3 instances that are available on AWS. And you can ask Kubernetes for the kinds of resources that your pod needs. So we have a TensorFlow pod. We say to Kubernetes, hey, this is a GPU pod. Please put it, schedule it, on a machine that has a GPU. And we specifically specify that we want some P2 or P3 instances to do this. And Kubernetes, as of recent versions, does support this. So this is functionality that came in more recently. And so I encourage you to try this out again if you have had discouraging results with that earlier. So and there is support for other coprocessors coming. You know, there's this landscape of coprocessors that is evolving other than GPUs. Intel, Qualcomm, and all these other companies, they're all building deep learning chips of some kind. And they all would like to be schedulable on the more popular cluster managers. So almost certainly they will add some support here. So you can expect that to happen. All right, so having said all of that, we're now in a fairly good spot to tell you what Matroid actually is from a user's perspective. So Matroid is a product that is for computer vision. It's a studio for creating and using detectors. So a detector is a term that I'm going to be throwing around a lot. A detector, much like a metal detector, will find metal on a beach. A Matroid detector will find things that it's been created to detect in video. So we're going to create a detector, and then we're going to have it run on some video. We'll do a lot of live demos, and hopefully none of them go wrong. I'm taking some risk here, but I'm just going to switch now, actually, to our live demo. And for probably a bunch of the talk, well, I'm going to do what I just mentioned to you and show you the pieces in action. So hopefully you can see this. Nope, you cannot. I need to exit the talk. So I'm going to exit that, go here, do that. Perfect. So when you log into Matroid, you get a screen that looks like this. You have one of two options. And by the way, this is now the Nginx pod. It routed us to one of the Node.js pods. And Node.js is presenting us with the web app that is being loaded in front of us. And so you have one of two options that you can do when you log into Matroid. You can either use a detector off the shelf, or you can make one for whatever the hell you want. This is our mission, is to let you detect whatever you want. As a computer vision company, we really want to take you all the way to detecting weird things that you might not have available in sort of custom model repositories, or I shouldn't say custom model repositories, but ready-to-use model repositories. Having said that, we do have a ready-to-use model repository. So before I make one model of my own that will get scheduled with TensorFlow and trained on the spot, let me use one of these models. So if you go into our public model gallery, there are all these models that are readily available. I'm going to pick one of these models and then run it right now. So this is a model, this is a detector that can detect airplanes, bikes, birds, and a bunch of other stuff, including people. So I can run this on me right now, actually. So let's do that. Hopefully it detects that there's a person there, and indeed there's a person there. But then more interestingly, it should work with some level of obfuscation. So I'm barely in that frame, and indeed I'm still there. Maybe just my hand there. It should figure that out. Hopefully it will figure out that there's a bottle, although not so clear there. And indeed, that there's a bottle in my hand, and there's me, right? So it sort of figures out that there's a person there. At some point, it's got to say that maybe this will say, sometimes it says I'm a sofa at that point, because it's like all it sees is my shirt. No, it's kind of confused there. It thinks the whole thing is potentially. I kind of want to see what it says there. This is risky and silly, but I'm going to do it. So let's see. It picked out. Oh, that's funny. It thinks the reserved seat is a bottle. That kind of looks like yeah, I can see that, but that's really funny. So I can take this thing and run it, this detector, and run it on a live stream. So we're actually going to run it on live Bloomberg right now. So let's see what it says about Bloomberg. Hopefully there's some people or something interesting happening on Bloomberg. Otherwise, this will be a wasted time. So it looks like there's some people on Bloomberg. Let's say we're looking for people there. And lo and behold, we found a person. And this is live Bloomberg, so I apologize if anything weird comes up. Market weight China data. OK. And now, less interesting, because there's no people in this one, right? So there's 0% per people here. And at any point, I can stop and say, well, yes, this is right or wrong. So there's a person coming up again. So I can stop this and say, well, yes, you are actually correct. And this will go back into making the detector better. I'll show you how that works in a second. So I say, yes, this is indeed a person. Let's see. So this is running live. What if I want to run 24/7 and then look back at my results? That's exactly what we have in another interface here that looks at the results for a long period of time. So this detector here has been running on a TV channel for roughly a week now. And on this TV channel, it's been looking for gender distribution, male versus female. So this is going to tell you what is going on Bloomberg with regard to gender distribution. So this is a woman, right? Of course, and it should be, and so these are all the people who are showing up on Bloomberg, tagged as with their gender, and of course there's some men in there as well, right? There's the president, right? Oh no, this is wrong. So here we made a mistake, right? So we're not. So I don't want live demos come with this kind of thing, right? I have to be honest about it. So there is plenty of although it made a mistake, it made a mistake that I'm very happy about. So that's enough of that. So there's right. So hopefully there's a man. You get the idea, right? So you can see things like insights on the detection. So turns out there's often slightly more men than women on this TV channel, and then sometimes there's pretty much the same. I've actually never seen this data before. Like it's changing, right? So it's all the time changing. You can look at what does the data look per hour. So this is one particular hour that looks like there are more women than men, but most of the hours there's more men than women, right? Probably this is 1 hour where there's a woman anchor or something. And of course, you could just see things like total detection. Sorry, that's the wrong one. Right, so total detections right there. You can share these reports and that you can set what you're looking for. So a schedule, and then of course, you can set I'm looking for a man with, say, 95% confidence and a woman with 95% confidence. And so then you only get notifications for when the detection is above the threshold. So all of this is sort of what you can do with a detector. I haven't created one yet. I just picked a general detector off the shelf and I ran it on a stream. That's useful, but it's not, and it does use a lot of compute power. So what you're seeing is 24/7 monitoring of a stream by a detector means we have to schedule a GPU machine, a fraction of a GPU machine, of course, to be running on that stream 24/7. And so this is part of the service that we provide. If it so happens that we're going to incur a lot of compute cost, then we charge in proportion to the compute cost, as we should, right? So this is all fine for the sake of a detector that's ready-made, but let's actually make a detector right now and use it. So how will I do that? Well, we went back to the front page and we're asked, what do you want to detect? So I'm going to create a detector for myself. And so I just met someone in the audience named Leah. She was sitting next to me, and I said, hi, will you be a volunteer? And she said, yes. So we're going to create a detector for Leah's face as well. And then, Leah, who's your favorite celebrity? I deliberately didn't ask you beforehand so that you would be on the spot. Ryan Gosling, all right. So we're going to add Ryan Gosling to this detector and add that in. So what's going to happen is we have our own mini search engine. We scour the web and look for people named Leah. Of course, this is not the Leah in the audience, so we're going to unselect all those results. There are some pictures of me. I'm going to deselect them and upload some new examples. So what happens is we're in studio mode now, and we're curating images relevant to who we care about. So this is, of course, images of Ryan Gosling. I'm going to add some images of myself super quickly, so I can just say, hit here and upload pictures of myself, a single image, or I can use the webcam. I'm going to take like a couple of photos of myself, save them, and then I'm going to ask Leah to come up on the stage, and we're going to take some real quick photos of her. Okay, so then Leah, clear that. So if you would just move your head to side, up and down. Perfect. Thank you. You might want to hang out for a little bit. Yes, so we're going to take a group photo. Yes, and then, well, actually, you should sit down and I'll ask you back up because we have to train and there's a bunch of other stuff here. So these photos of Leah are being quickly uploaded. So now we have Leah in there, right? So there she is, and there I am, and there is Ryan Gosling. So we can of course bring in data from all kinds of other places. One other place that we have our own video player involved is through a video file. So if I select a video file here, I can flick through the frames of this video file at any point, pause, and flick through the frames, and then say, I want this frame, this frame, this frame, this frame. I upload them as before, and then I go in, and then I can select exactly where the relevant, person, the person is. So there is what is supposedly Ryan Gosling. Of course, it's not Ryan Gosling, so I will have to deselect this afterwards. And so now we have a bunch of examples of Ryan Gosling. I'm going to deselect them because that is definitely not him. And I'm going to quickly browse through, oh, there. Yeah, so some of these pictures, I apologize if they're weird. I don't need so many examples, so I'm actually going to X out all of these other pages because I don't really want to go through them. The more pictures you have, of course, the better this thing will get. But we only need 1 or 2 pictures of a person to build a detector off of them. And one last thing I wanted to show you is if you're going to run a detector on a stream later, as we did, you might have some weird glare, or you might have some weird things in the stream that are confusing the detector. And in those cases, you would like to normalize them out by uploading examples from the stream into the detector. So this is actually a live stream of our office. I sit right here when I'm in the office. And I can record from this stream and then include those frames in the detector. So this is Julian, one of our web developers, and he has a recording here that I could have used to create this detector, and then I can normalize for this weird fisheye that is on this particular stream, right? If I upload these examples, I can learn more about that fisheye. So I have all these things here ready to go. This is going to be a face recognition detector, and then I'm going to hit train. This should take around 2 minutes, so it's 5:09 right now. This should be done by 5:11, hopefully. And let's give this a name, so we're going to call it the AWS 2017 detector. So what's happening here is actually one of our bank of machines from the Kubernetes pod that owns the TensorFlow workers went and talked to the pod that owns the database. In the database, there was a pending detector job. One of the workers went and picked that out, said, hey, this is a pending detector. I'm going to take this, and I'm going to go train it. And then it went and started the training job on that GPU instance, and it's busily working away. And I'm pretty sure this is actually running on a Spot instance, because Amazon's been nice enough not to destroy this Spot instance. If the Spot instance were to be evicted, you'd actually see the progress bar go back to like 10%, which is roughly when the database entry is made, and then the thing would start going forward again. So that sometimes happens, but quite rare. So we're almost done with this. And then when it finishes, I'm going to ask Leah and Co to come back. Meantime, I'm going to go look for a video of Ryan Gosling on YouTube so that we can run it through. I have never seen. Leah, which YouTube video would you like? Jimmy Kimmel? All right. So let's just copy that. I have the URL saved, and it's ready. So would you like to come up? And maybe like 2 other people come up, 2 random people. You guys would like to come up? No? You don't want to come up? You want to come up? Please, yeah, come on up. And so we can take a group photo here of all of us together. So then we should be able to see what's going on there, right? So there's me, and there's Leah, and there's someone who is neither Leah nor me. And so it should be able to handle some amount of occlusion here. So let's see. So I'm only half my face is in there, right? But it's still just fine, and it's OK. You guys, thank you, thank you. Yeah, please. And I can send this detector to you later, and you can delete it if you want. So some level of obfuscation is very much possible. So I can cover my mouth, one of my eyes, but at some point it should sort of peter out, right? So there we go. At this point, it's not sure what's going on in the image, right? So this is something we care about. We do care about obfuscation. You saw it with the person detector. You saw it with this right here. Okay. So let's go run that video, right? So what's going to happen is I'm going to dump in this YouTube video, which I've never seen. So I apologize if it has some bad things in it. Jimmy Kimmel should be, actually, no, this is late night, so I'm going to, yeah. I'm going to, yeah. So look, it's already saying there's some Ryan Gosling is showing up, right? So this is live. Again, one of those workers took this video, downloaded it from YouTube. At the same time as you're watching the stream from YouTube, the classifications are rolling in. This is our own video player. It is annotating the video with what's going on. And so we think that Ryan Gosling shows up. He's gone for a second here because he's looking to the side so much. But here, he should be gone like totally. Oh, again, he's looking to the side. So we're just not sure that that's him. I guess when he's looking to the side, we don't get him, right? So here, when he's very much looking straight on, there's just no mistaking that that's him. Right? So I guess it's not that interesting a video. It just like does the same thing for a long time. It'd be really cool if we could have gone to do other interesting things, but the video to have other interesting things going on. So, oh, there we go. Like all these people did not get confused for Ryan, right? None of them got confused for Ryan, and even Ryan's side face is getting picked out now. So let's see what's going on around the end. Sometimes at the end of the show, they do some different stuff. Nope, it's really just, it's one of the more boring interviews, I guess. I didn't pick it. No. Yeah. So you see what's going on here. Side faces are quite hard. We actually didn't have many examples of side faces of Ryan. So let's see what examples were. Most of these examples were dead-on faces. So if we actually had some side faces of him, we would have started getting the side faces. We have an entire different model for side faces, and that would kick in. So let's go back to the, whoa. Let's go back to the detector here. So everything I showed you is available via an API. You can create detectors, use them via an API, many different programming languages, and these are the REST APIs that are presented here. We can try this on a stream. Very interestingly, we can give feedback. So if I run this here, and I say, well, who's this? Of course, it's me. But then I say, yes, that is indeed me, right? When I hit redo detector now, what will happen is we'll land back in studio mode with that additional example of me. And so that's the additional example where I said, yeah, this is me. I guess it's not the clearest, but yeah, that's what's happening to the feedback. It's going back into the studio, and then you saw how quick training was, so I could just hit retrain again now, and I'd have a new detector that would have that feedback as part of it, so you can continually make detectors better and better. So so everything I've shown you is drag and drop, point and click. No programming needed. What if I was a deep learning engineer and I wanted to look at the insides of this detector? For that, there's actually a whole different part of Maitreya that is built off of open source, and in particular built off of Tensor Flow. So I'm actually writing the book on Tensor Flow with O'Reilly, and a part of it is how to use this particular screen that's coming up. It takes a little bit longer to load because it's heavier duty. So what you'll be able to see is the insides of the model. So things like what is the accuracy of the model, what are the different things that the model is confused about. At the same time, I'm going to roll another one of these just in case that one is being funny. So I have another detector. Actually, I have another detector here that detects tables and chairs. And in this one, there's some more interesting examples of mistakes. So the detector that I showed you, here we go. The detector that I showed you is going to be a pretty good one because it's faces, and we're pretty good at faces. But we have a table and chair detector that I deliberately made slightly worse. It's not as good a detector. And then to check that, if you hit Maitreya board, you can see the accuracies for that detector for chair and for table. You can see some of the mistakes that the detector makes on its own training examples. So these are the mistakes that the detector makes for table and chair. There's this weird chair embedded inside the table. It's like some kind of chair art. I don't know. And then there's flowers on the chair. Usually when there are flowers on something, it's a table. And there are all these other examples where there's some weirdness going on that it's not clear whether it's a table or chair. That sometimes it's both. I can also look at an embedding of the data here. So this is an embedding of the chair table examples and the chair examples. The colors are the true labels. So if a thing is orange, it is a table. If it is blue, it is a chair. And the position in space is roughly what the detector thinks about what this blob should be. And so if you see a clear clustering, then the detector's learned the difference between a table and a chair. If you see a mishmash of points where there's no coherent clustering, then it's learned nothing. Here we see that it's at least learned something. And there is some very clear clustering, but there's also this middle ground in which there are overlaps. And there are these examples that are very close to each other that are of different color. And these are the examples that we should exactly focus on. It is these examples that the silly mistakes were made on. And so if I were creating a detector and modifying it to make it better and better, I would give feedback here, retrain it, and then I would have a better detector available to use. Right? So this is all available to us for the sake of trying out a detector and seeing how it works. So we have I believe that's all for my live demo. Yeah, that is it for my live demo. So with regard to AWS today, more recently you heard about the Amazon Kinesis video streams. And so what I'm actually going to announce here for the first time is that we are going to be embedding and allowing you to monitor an Amazon Kinesis video stream by using these detectors that you can build with click and drag on Maitreya. So this is actually quite exciting. We were working with the Amazon Kinesis video team leading up to AWS reInvent, and this is essentially my promise to you that by the first quarter of next year, we will have the ability to just point us to an Amazon Kinesis video stream and have that stream monitored for whatever the hell you want. Those streams are going to be integrated with a whole ecosystem of things that Amazon is either already telling you about, or you might have seen already in Andy Jassy's keynote in the morning. So we're going to get close to wrapping up now. So I'm running the book on TensorFlow with a student of mine, Bart, at Stanford. He's been phenomenal in writing this. And there are anyone who's interested in reading a draft of this and giving us comments in return, I would love to hear from you. So we're about to essentially publish it. But last round of comments would be very much appreciated. So at Maitreya, we have a lot of phenomenal partners. New Enterprise Associates and Intel are our partners and investors, and they have we've raised $13.5 million from them, and so and this was just a couple of months ago, and so we're very much looking for help to build out all kinds of parts of Maitreya, whether it's Kubernetes, TensorFlow, deep learning in general, and web engineers. We'd love to work with you, so please talk to me about that if you're interested. So the next step would be for you to try out Maitreya.com yourself, and if you're interested in running a Kubernetes cluster on AWS, this is a link available to you right here, so you can do that. It's the end of the day. I don't want to keep you for too long. You've seen Maitreya, you've seen how it runs, and the least I can ask for is that you give us some feedback when you try it out. Thank you, and let's take questions.